Alright, so we did the first two steps of example 2 in the last video, and now we're actually going to get our data and be able to do our math for this video. So in order to test this, we took a random sample of 30 American adults from each of the 50 states. Each person was asked if they approved of the president or not. From our sample, we found that 651 of them approved of the president. So now we're going to complete steps 3 and 4, well, most of step 4, of our hypothesis test. So let's first, now we have our data, so let's figure out some things that we should know. First, from reading my example, I should know what my sample size is. So I sampled 30 adults, but from each of the 50 states. So I have 1,500 people in my sample. I should also know what my p-hat was. So what proportion of my sample approved of the president? Well, that would be our 651 out of those 1,500 people that we sampled, which gives us a p-hat of 0.434. Now, just glancing, notice that that number is higher than that 39.9%, but we've only sampled 1,500 people, so our kind of real question is this value enough higher to really say that his approval rating has gone up for all Americans, not just our sample? So that's sort of the goal here. All right, so if I look at what step 3 is, step 3 starts with our conditions. So first, talking about that sampling method. So if I took 30 American adults from each of the 50 states, what I've technically done here is a stratified sample. And from the way that it was done, again, I don't really see anything I know that's bad with how they chose those people. Nothing intentionally is bad. Next, we want to take n times p0. So our n is at 1,500. You remember that p0, that little 0 is there to remind us to go up to this 0. And so we're going to use this 0.399 to do our math here, which gives us 598.5. And yes, that is at least 10. And then our n times 1 minus our p0 is going to be 1,500 times 1 minus that 0.399, which gives us 901.5, which is also at least 10. So now my conditions are met. I can also now calculate my z. So going back and looking at the formula for z, so p-hat I know now, that's my 0.434. p0 we just used in those conditions to be 0.399. And we also know our n is our 1,500. So I have all of the numbers to be able to calculate my z. So again, our p-hat is at 0.434. Our p0 is the 0.399. And on the bottom, we've usually actually already had this number calculated, but I don't, so I'm actually going to write it out with that square root piece on the bottom. Again, that bottom part is our standard deviation of p-hat that we're looking at down there. And I'm just going to show an in-between step, because I know some of us aren't comfortable trying to do this whole calculation at once. I'm going to show my numerator and denominator here for you. So for the top, we should get 0.035 to be our difference between those two values. And that square root piece, the standard deviation on the bottom, I should get 0.012644. And now finally doing that division then, I should get a z of 2.77. So that's what step 3 looks like. So step 4 is to calculate our p-value, or another, again, fancy name for probability. So let's go back and look at that Chantix example where I drew a couple of different pictures. Because I'm going to get away from drawing this picture and just draw this one. If you remember, we showed and talked about how these two are equivalent pictures. Because I use this point to calculate this z-score up here. So my z is always centered at 0. And I'm always looking at number of standard deviations away. So the negative just means we're below the mean, versus a positive would tell me that I'm above the mean. So how would that mean our picture would look like for step 4? So now that I'm drawing my picture based upon z, z is always centered at 0. And the numbers I would put on here are always just looking at how many standard deviations away. And so this is a much easier picture to draw each time, which doesn't change, right? Because z is our way of standardizing things. So my z picture is actually always going to look the same, which is really nice. But so where am I actually using my data, right? To calculate this 2.77, I used my data that I got, my 1,500 people and 651 approved of the president. I'm using all that data to calculate this 2.77. So when I put this number on my picture, keep in mind that if my data changed, that value would change as well. Now we have to ask ourselves of what should my picture look like shaded wise. So first let's talk through one-tailed versus two-tailed tests again. So if I go back and look up at my alternative hypothesis, I'm only looking in one direction. I'm only looking for that greater than. So I know I'm only going to have a one-tailed test because I'm only looking in one direction. Now the question then should be, should I shade left of 2.77 or shade right? Well, we're looking for greater than, so we're also going to be looking for greater than this, telling us to shade right. It's also a little helpful tip that notice that the sign will point the way that you're going to shade. So because my alternative has that greater than sign in it, that means I'm going to shade to the right of my value. So now I know when I go to my table, I'm going to have to use that 1 minus rule. So let's go through and actually do that. So then my p-value, or again just our fancier name for our probability, is going to be 1 minus, and again just because we're shaded right, it's going to be that 1 minus. And if I go to the table and look up my 2.77, I should find a probability of 0.9972. But again, I have to do the 1 minus of that value, and so I'm going to get 0.0028. So that's the goal of this video, is just to talk through the math. Because again, the math that we're doing here should be no different than what you felt like you were doing in the previous module. We're maybe making it formal a little bit, drawing a slightly different picture, but the math we're doing here is really the same as it was before. So again, I suggest watching the last video right away, because we're going to take this math and figure out, well, what does that actually mean now? Did the president's approval rating increase or not? That's the goal of the next video.